Now we are going to solve a problem using star delta transformation. Star to delta or delta to star transformation. So we have a circuit like this and we have been asked to find out the total current drawn from the battery using star delta transformation. So we can calculate the total current drawn from the battery using mesh analysis, but here it is specifically asked to calculate the total current using star delta or delta to star transformation. Okay, so let us check the circuit and find out where we can apply this transformation, if there is a star connection in the circuit or if there is a delta connection in the circuit. So see, so there are two delta connections in the circuit. So this is one delta, this 5 ohm, 1 ohm and 4 ohm resistors together form a delta connection, and this is another delta, this 2 ohm, 7 ohm and 1 ohm together forms a delta connection. So we can transform any one of this delta connection into a star connection. Okay, any one delta circuit can be converted to a star connected one, and then we can proceed. So I am going to choose this one, this particular delta connection. So for the ease of representation, I am going to name the terminals. So as we are marking in the case of a delta connection, I will be marking this terminal as 1, then this as 2 and this as 3. So if we mark terminals like this, we can easily write the value of resistors. When we are writing the equation, we can easily represent the resistors. So that is why I have marked the terminals like this. Okay, so I have chosen this particular delta and I am going to transform this delta into an equivalent star connected network. So when we are calculating a particular delta into a star connection, the equivalent star resistors will come like this. Okay, one resistor will be here in between terminal 1 and terminal 0, and one is here between terminal 0 and terminal 2, and one will be here between terminal 0 and terminal 3. Okay, so now I have to calculate this resistor and this resistor. So while I am writing the equation for these three resistors, I can easily denote their names as R10, R20 and R30. Okay, for that I have marked the terminals. So if we are marking the terminals like this, we can easily name these resistors. Okay, so we have a delta connection. I have chosen this delta connection, and if we transform this delta connection into a star, the equivalent resistors will be like this. Now we have to calculate R10, R20 and R30. Okay, let us calculate R10 first. So R10 will be equal to, R10 is equal to the product of the two resistors which are connected to terminal 1, that is 5 into 4. So let us write the equation also. For the time being, let us write the equation also. So R10 is equal to R12 into R13. R13 divided by the sum of all the resistors, R12 plus R23 plus R31. Which is equal to R12 into R23 is 5 into 4. 5 into 4 divided by R12 plus R23 plus R31, that is 5 plus 1 plus 4, that is 10. So 20 divided by 10, which is equal to 2 ohm. So the resistor to be connected between terminal 1 and terminal 0 is 2 ohm. Now let us calculate R20. The R20 will be equal to the product of the two resistors connected to terminal 2, that is R12 into R23. R12 into R23 divided by sum of all the resistors of the delta, R12 plus R23 plus R31, which is equal to R12 into R23, that is 5 into 1, divided by R12 plus R23 plus R31 is 5 plus 1 plus 4, that is again 10. So 5 divided by 10 or 0.5 ohm. So the resistor to be connected in between terminal 2 and terminal 0 is R20, that is 0.5 ohm. Now the third resistor, that is R30, and R30 will be equal to R23 into R31. R23 into R31 divided by sum of all the resistors of the delta, R12 plus R23 plus R31, which is equal to, see, 4 into 1 divided by 10, which is equal to 0.4 ohm. So we have got the 3 equivalent delta resistors. So I am going to note down these values here. R10 is 2 ohm, R20 is 0.5 ohm, and R30 is 0.4 ohm. So now let us redraw the diagram by replacing the delta by the equivalent star that we have calculated now. So we are actually transforming a delta into a star. So we have transformed and we have calculated the value of equivalent star resistors. So we have transformed a delta into a star. So now we have to represent the equivalent star only. The delta is not needed here. Okay. So we can't replace delta. So you should not do it like this. You have to redraw the diagram. Okay. In each case, you have to redraw the diagram. I'll draw it again. Okay. We have to replace the delta by the equivalent star that we have calculated. Okay. See, we are replacing the delta, original delta network which was there. Okay. So on replacing the delta by the star, the network will look like this. So there is a resistor between 1 and 0, then one between 0 and 2, 0 and 3, like this. Okay. So now see the network. From this particular network, it is clear that these two resistors are in series. So let me write the value of the resistors also. R10 was 2 ohm, so this is a 2 ohm resistor. Then R20 was 0.5 ohm and R30 was 0.4 ohm. Okay, so we have 1, 2, 3, let us mark it as 4. Okay. Now from the diagram it is clear that these two resistors are in series and these two resistors are in series. Then this series connection is in parallel with this one. Okay, let me draw it. So I am going to draw the resistance part only. See, so there is terminal 1 here, and between terminal 1 and 0 we have a 2 ohm resistor. Okay, between terminal 1 and terminal 0, and see, this 2 ohm is in series with 0.5 ohm, so we'll get the equivalent resistance as 2 plus 0.5, that is 2.5. Ohm here, and in the lower branch also the 7 ohm is in series with this 0.4 ohm resistor. So 7 plus 0.4, 7.4. 7.4 ohm. Okay, this is terminal 4. Okay, so these two are in series, these two are in series. Then this upper branch is in parallel with this lower branch. So the equivalent circuit will be like this. So we can again simplify the circuit. So 2.5 is parallel to 7.4. So we can calculate the equivalent resistance of this particular combination as R equivalent is equal to, these two are in parallel, and that parallel combination is in series with this resistor, that is 2 plus 2.5 parallel to 7.4. So this will become 2 plus 2.5 into 7.4 divided by 2.5 plus 7.4, and the answer will be, the equivalent resistance R equivalent is equal to 3.868 ohm. Okay, so the equivalent resistance of the circuit that we have considered is 3.868 ohm, and we have to calculate the total current drawn from the battery. So total current drawn from the battery will be equal to, I is equal to V by R. So total current is equal to total voltage divided by total or equivalent resistance of this combination. That is, we can write the total current drawn from the battery. Drawn from the battery is equal to total voltage divided by the equivalent resistance, that is 10 divided by 3.868, and this will be equal to 2.584 ampere. So this is the answer. Okay, so while we get a problem for star delta transformation, first of all check the network and identify the star or delta connected delta meshes if it is available in the question, in the circuit. First of all, clearly look at the circuit and see if there is a star connection or a delta connection available there, and if so, then we can transform that particular connection. If a star is there, it can be converted into a delta, and vice versa. Okay, likewise we can simplify the given circuit.